A Tutor's Guide Through Algebra. Direction matters. But first, some vocabulary. Addend represents one of the items being combined together during addition. Operand, a single piece of data which is separated by an operator. Operator, that is the actual action or process. Operators include addition, subtraction, multiplication, division, raising to a power, or finding the root. Sum, the answer or result if the operation is addition. Difference, the answer or result if the operation is subtraction. Inverse, that is the opposite operation. The inverse of subtraction is addition, inverse of division is multiplication, the inverse of a root is finding a power. The identity number is a number that, when it is added, will give the same result for both operands. The identity number for addition and subtraction is 0. The identity number for all other operations is a positive 1. Now here's a basic problem. 1 plus 2 equals what? Well, let's do some visual representation here. We'll change the 1 to 1 pink circle and the 2 to 2 blue circles. If we add them up, how many circles do we have? We have 1, 2, 3 circles. The illustration with the circles is what is a basic elementary one. However, there is also direction. If we start with 1, we go 1, 2, 3, 4, 5. The numbers are increasing, and when we write them out, we would write them from left to right. If we think about a direction, that would be like going to the east. But numbers also go in the opposite direction. -1, -2, -3. So the opposite of east is west. We have two opposite directions in math. But we don't write east or west. Instead, we write positive, which represents numbers to the right of 0, and negative for numbers to the left of 0. Okay, the number and sign convey two different pieces of information. The direction from 0, which way it's going away from 0, and the distance. Here I have put in 1 unit from 0 to positive 1. That gives me a measurement of 1. We also have a measurement of 1 going from 0 to -1. It again measures the same, but they are on opposite sides. Putting it together, this is what it looks like. 1 unit to the right is in green, 1 unit to the left is in red. If I was to measure that, they would be the same measure. Okay, it's always a good idea to use tools. One of the basic tools is using a number line. It's better to visualize instead of going around blindly. Okay, now here we have a problem. -8 plus 3. Eventually we're going to be using the number line, but how do we do this? Well, first of all, which number is further away from 0? Well, we can use the number line and count. If I count, I'm going to go 8 units to the left and 3 units to the right if I go positive. So I had to count further to get to 8. Why is this important? Well, because I need to know what the sign is. The sign of the larger unit further away from 0 is what we're going to write down first. So in this case, 8 was further away from 0, so we will write down the sign first. Now this is important to take care of the sign first and then the number. Okay, the next question you ask, are both the signs the same? If they are, we'll add the numbers together. If not, we will subtract the smaller number. Okay, in this case they are not the same. So we will take 3 away from 5, and that gives me 5. We'll write this number down after the sign. So now we have 8 plus 3 equals a -5. Well, not only do we have a -5 here, but here is a visual that shows this. We go 8 units to the left, stop, turn around, and go 3 units to the right. Where do we end up? The purple sign shows at a -5. Okay, now we're going to use a technique that's called known to new. Take what you know, write it down, and then if you are trying a new technique, write it down and see how it correlates. Okay, so +5. Add to that a +2 gives me +7. Same signs, we add the numbers together. Now I've got a -5 and a -2. what would my answer be? Don't look at the gray one right quick. Okay, well, in the first one, my signs were going in the same direction, so we added it together, and they had all the same sign. So therefore, if my signs are the same, just like in the pink, my number has to have the same sign. You just compare them. Okay, now here's another one that's coming up. We're going to use where a number is larger, it's going to be negative. Now, how do we do this? We have a positive 8 and a negative 3 equals a positive 5. Now, if I want to find out what happens if I have a negative 8 and a positive 3, all I do is write that down and see how the signs line up. Okay, this mnemonic device is mine. All the same. Do you see that the word all is in purple? We're going to relate that to addition, and same for subtraction. Okay, what I mean by all the same does not mean that I can only add 3 plus 3. Clearly we know that. What we mean in algebra is that the variable and the power must be the same. So x and x squared cannot be combined because one has a power of 1 and one has a power of 2. The rest of this will be discussed in another slide segment, but that will get us through the basics. Okay, for more information besides the basics, you can go to www.myspace.com/atutor and contact me that way, or send me an email. My email address is a_tutor@suddenlink.net. You can also purchase my ebook. It's called The Mathematician, The Basics, also known as The Order of Arithmetic Operations. That can be purchased through www.lulu.com/content/2139805. The cost of that currently is $1.25. So any feedback would be greatly appreciated, and thank